The opening of stomata is accomplished in response to blue light when blue light hits a receptor. So there's blue light hitting a receptor. When that receptor gets hit by blue light, it changes shape. And that generates the beginning of a signal transduction pathway that leads to the speeding up of the already functional proton pump. So before blue light hit, the cell had this is a guard cell, had a resting potential, let's say of minus 100 millivolts. After blue light hits, both of these signal transduction pathways seem to lead to an increase in the rate of proton efflux. So the proton pump is burning more ATP, and consequently, you get a hyperpolarization of the membrane. It's becoming more polar. The millivoltage across the membrane is now down to minus 120, say. Now, this is a big physical change. As a result of this physical change, a result of this change in membrane potential, you get the opening of potassium channels and the activation of chloride ion cotransporters. Potassium channel opens, potassium enters. Why does potassium enter? Well, it's being driven in by charge. All of that added charge differential means there's an even stronger force driving potassium in. And so a concentration gradient of potassium begins to form. There's now more potassium inside the cell than outside. Because chloride is a negatively charged ion, it isn't sufficient, or charge is actually, this increase in charge makes it harder to get that chloride in. And so the protons that are being extruded by the pump are being used to drive chloride into the cell. Now, both chloride and potassium concentration increases mean that there's more solute. Both of these are solute, and so you've increased the amount of solute in the cell. If you increase the amount of solute in the cell, then you've decreased the osmotic potential of the cell. And if you decrease the osmotic potential of the cell, that is going to attract water into the cell through an aquaporin. And when water concentration, or when water volume increases, increased volume leads to increased pressure potential. That increased pressure potential causes the stomata, the guard cell, to change shape. And so it went from its original shape like that, and here's its partner cell, there's your closed stomata, to something looking more like that. And this space in here is the stomatal pore. And so by increasing the size of that stomatal pore, now more carbon dioxide can enter the plant, but sadly, more water will leave the plant through that space.